Well, good evening, everyone. I'll go ahead and get started. My name is Arnold Gelb. I am an auxiliary instructor, AUX Op, and also serve as a branch chief in the training directorate. And I wanted to thank Bob for inviting me back to provide another lecture tonight on the home stretch for Chapter 7 in AUX WEA, which is Observation and Forecast Data Sources. The first section is on sources of observations, and the overview is that we're going to first talk about a review of surface charts and mention analyses, combination products, then turn to briefly touch on radar data. We'll talk about local radars as well as regional and national summaries. We will then look at satellite data, look at the different types of orbits and satellites and wave bands, and then discuss a little bit about upper air charts. And to begin, when we think about surface charts, these are analyses and they're produced quite regularly every 3 hours. And the valid times will be at Zulu or Greenwich Mean Time, and then every 3 hours, so 3 Zulu, 6 Zulu, or 6 GMT, etc. Of course, then you have to adjust it for the time zone that you're in relative to Greenwich Mean Time. It contains isobars as well as indications of both a high and low pressure centers and their fronts, and often show areas of precipitations. Depending on how they're assembled, they may or may not include station models. There are quite a few different formats out there, and sometimes they can be combined or overlaid with radar or satellite data. The best approach is not to look at an individual chart, but to look at a series of charts over the past 6 to 12 hours so that you can identify trends. And in these examples, in the chapter from your book, most are for a single date and time from December 2014 as indicated, or are forecasts based on observations at that time. And there's a link available for you to have for study. So here is an example of a surface analysis chart, and the most prominent features on this chart, as you can see, is the sort of high pressure areas. I'm sorry for that. Over the Great Plains states. There is also a large split with a large high pressure area over the Plain States, a large split with 3 separate low areas over Lake Michigan in Superior, as well as Wisconsin. And then we see that there's an extensive cold occlusion that comes down here over Ohio, Kentucky, and Tennessee. And later on, we're going to compare these surface features with the 500 millibar chart. Now, this chart shows, again, a same analysis as we saw on the last one, but it covers the larger area of all of North America. And in here, just want to draw your attention to the deep lows that are off of the coast of Canada. In addition to what we were seeing in the continental United States, of the highs in the Great Plains, and then in the Midwest region, the other lows. Now here, what we've done is overlaid the first chart with radar, and Note the extensive area of precipitation that you can see here with the stippled dots around the low pressure systems. And finally, this is the same analysis as we had seen initially, but now overlaid with satellite data. And the brown and yellow colored areas are clouds that are mostly cirrus clouds. And then over the Great Plains, you have extensive low clouds, which are pseudo-colored in green. Turning now to radar, today's radar for weather are Doppler radars. And an advantage of Doppler radar is that can measure the speed of precipitation either toward or away from the radar. NEXRAD radars were developed jointly between DOT, DOD, and DOC. There are 160 located in the United States, as well as a number overseas for the military. And these can see precipitation, clouds, and air turbulence. These radar images are available in several different forms. That can be single local radars, regional mosaics, or national mosaics, which are essentially stitching together the information from multiple sources. And these are available at the link shown here. How does weather radar operate? It works on the principle of emitting electromagnetic energy in the microwave portion of the spectrum, and the energy reflected from clouds or precipitation are then received, amplified, and shown on a display. The position is based on the direction of the antenna pointing and the time elapsed between transmission and reception. And if precipitation is heavy, the energy may not be strong enough to provide a return from longer distances. And with ordinary radar, mesocyclones are represented by a so-called hook echo, and this indication really is not that reliable. But it can be overcome by Doppler radar, as we'll see shortly. I just wanted to introduce one slide just to make, I think, apparent the Doppler effect a little bit more clearly than I think than the other materials do. And this uses what I think a lot of people have heard when you hear, say, a police car coming towards you with a siren. It has an increase in pitch or higher frequency. And this is because due to the relative motion of the car, the sound waves become closer together. And this is therefore you see more of them in a given period of time, or hear more of them in a given period of time. And therefore the pitch appears higher to you. Similarly, if you're standing on the other side of the car and it's receding or going away from you, as it moves in a given period of time, fewer of the sound waves reach you, and therefore the frequency is lower, and therefore the pitch is lower. And from the appendix in your book, it provides an equation for this, and this is fancy, but essentially what it means is that the shift in the length of the waves over the actual wavelength, so it's just essentially a proportion, is proportional to the velocity over the speed of light, or the speed relative to the speed of light. So it just means that this shift that you're seeing is proportional to how fast things are moving. And that's why it's very regular, and that we can assign on a display pseudo-colors to it. And if we move then to this slide, this talks about how this Doppler radar is used for weather. So precipitation moving towards the station increases the frequency of the radio waves, whereas if wind is blowing precipitation away from an antenna, the frequency or reflective radio waves is lowered. And Doppler radar detects these frequency shifts and use them to show wind patterns. And interestingly, the Doppler effect is effectively doubled in the system. And the other point is that it tends to show radial motion only. Now, how do we use this? Well, here this shows a Doppler detection of a mesocyclone. And remember, mesocyclones are on the order of 2 to 6 miles, often associated with thunderstorms. And here, if you look between the arrows, well, first of all, the green is showing movement towards the radar station, which is located at the yellow dot here. And red is showing motion away. And if you look here down near Enid, between these two arrows is a mesocyclone. There's an area of green, there's an area of red. Possibly could be a tornado. This slide shows the 160 NEXRAD locations throughout the US, Alaska, Hawaii, Guam, and Puerto Rico. And then there's a FAA radar site in Cuba, as well as some other ones overseas that military have access to. This shows local radar data, and this is from Wakefield, Virginia, and it shows reflectivity or speed of rainfall. You can show or hide backgrounds. You can display roads, counties, etc. You can include the topology, as you see here. Can display warnings. It updates automatically. In fact, you can loop this radar display, and if you did so, it would show motion to the northeast as part of the circulation around the low pressure system here. Warnings can be included, for example, for tornadoes, severe thunderstorm, flash flood, marine weather, and the looping interval can be up to an hour. As far as regional radar, this is a mosaic display. There's an update every 10 minutes. It can be looped. It includes 10 CONUS, and CONUS stands for contiguous United States, as well as Alaska and Hawaii. It includes reflectivity only. There's no Doppler, and it can be accessed from the local forecast page. Data from individual radars are effectively combined by software to produce this composite display or image. And the 10 here were from the northeastern United States. Now, this is a national radar mosaic, and it's a composite of approximately 60 radars, those in CONUS. And the scale on the right here is in decibels, much as decibels are used to represent the strength of sound. Here it's being used to represent the relative strength of radar return. And now we're going to switch to talk about satellite data. So weather satellites are in two types of orbits. One is geostationary, which would be over a fixed point on the equator at an altitude of approximately 36,000 kilometers. And then there are also polar orbiting ones that are sun synchronous in the morning and afternoon, and at orbits that are much lower, so they can provide more detail at 850 kilometers. The geostationary or geosatellites include so-called GOES, which are the geostationary operational environmental satellites, and operational as GOES are goes east at 75 degrees west and goes west at 135 degrees west, with a spare that's in between at 105, so it can be shifted in either direction. Then there's also Meteostat, which is from the European Union. I just wanted to skip ahead for just one moment. And here, this is an additional slide, but I just wanted to show you that the 75 degrees comes down through Canada, through part of the Northeast, and the 135 is actually coming down through Canada between the continental US and Alaska. And 105, as you can see, is very approximately towards the just to the left of the center of the United States, so it could be moved in either direction as needed. Then we have the polar orbiting satellites that include NOAA and the Defense Meteorological Satellite Program. And again, the Meteostat is from the EU, and METOP, which is the polar orbiting satellite, is also from the EU. Then there is several different bands of data. One is visible band data. So goes east is visible data. It uses sunlight that's reflected from clouds, and DMSP can use moonlight. So the military has that advantage. It shows all clouds, and it's difficult, though, to determine the cloud height. Here, notice that there is a cyclonic circulation around the low in the Midwest and the Michigan area, and there's an anticyclonic, in this case, a clockwise motion over at the Atlantic. Then we also have an infrared band data, and goes east. Infrared 1 data is shown here, uses infrared emitted by clouds by the ground. It shows the temperature, and you can see the temperature scale on the bottom. Colder corresponds to higher clouds, and warmer corresponds to lower clouds. Doesn't show low clouds very well, and again, false colors are assigned using the scale that is on the bottom to provide contrast, and the color scale goes from warmest on the left to coldest on the right. Note also that the cyclonic circulation that we saw previously is even more evident in the infrared data, and you can also see part of it off the east coast of Canada. And then lastly, we have water vapor band data, and here goes east water vapor data. This shows the total amount of water vapor in the atmosphere. It's useful for identifying large air masses, shows circulation patterns, but you can't see under thick clouds. And the color scale is driest on the left and wettest on the right as you look at the bottom. Switching now to upper air analysis charts. These are produced for valid times of 0 Zulu or Greenwich Mean Time and 12 Zulu, so twice. And then at various pressure levels of 1,000, 850, 700, 500, 300, and 200 millibars. The 500 millibar chart is generally the most useful. It shows warm and cold advection affecting surface features, convergence and divergence affecting lows and highs. There are ISO heights, so lines at the same height that are measured in decameters or tens of meters spaced at 6 decameters. And then isotherms, which are lines of the same temperature in degrees Celsius with spacings of every 2 degrees. The jet stream shows up best on the 300 millibar chart and includes isotachs or lines of the same speed. And 700 millibar charts are useful to avoid most mountains. And the 850 millibar chart is very useful in flatter terrain because you're getting high enough to sort of average out and avoid focusing on local effects. So here is an example of a 500 millibar analysis chart. And on this chart, there are actually 4 different areas of cyclonic flow. And these are in the form of cutoff troughs for the lows that are in red. And then there is an extensive, and in these you can see, I don't know if you can follow my cursor, but the lows proceeding from left to right, those 4. And then there's in blue a high, which is a ridge that appears over the Rockies. And in this type of chart, the dark lines represent the ISO heights and the dotted red lines, the isotherms. A few other things to notice. There's cold advection east of the ridge and warm advection east of the central troughs. And these are causing rapid motion of the surface features to the northeast. The trough over, essentially over northern Minnesota, doesn't show up at the surface because it's a cold core low. And note that the area of concentrated isotherms are coldest are present in the center of the chart. Now this is a 300 millibar analysis chart, and here you can see the polar jet stream that is being traced in green for emphasis. Note that it's neither uniform nor, if you look at the rest of the chart, truly continuous. The short regions of lower wind speeds are typical of troughs. And this then shows the 850 millibar analysis chart. And this low altitude chart looks much like the surface chart overall. Note that the cold core low, though, is completely absent at 850 millibars. And in many ways, though, this chart can be very useful, more so than the surface chart, for showing the general low-level circulation, since at this altitude, friction and local effects are largely absent, except over very high features such as the Rocky Mountains. Okay, now we're going to move on to section 2, which provides a basis of sources of forecasts. And we'll talk a little about forecasting methods, including persistence, trend, analog, and climatological. Note that, as we'll talk about, analog is short for what used to be called analogy or pattern, not the exactly like analog versus digital. Then there's numerical, ensemble, and model output statistics. We'll talk a little bit about chaos theory and its impact on accuracy. We'll talk about some forecast product examples, such as surface prognoses, precipitation forecasts, and marine forecasts, and where to find these for auxiliary operations, various websites. You can use your WX channels on your VHF marine radio, as well as even smartphone apps. So let's start talking a little bit about forecasting methods. So prior to numerical forecasting, other methods were used and still are for certain applications. Persistence forecasting assumes no change day to day. If you're in San Diego, or if you're in Arizona during a short march of days in a particular season, one day is pretty much like another. So it's useful in areas like this where the weather doesn't change that much. Then there's trend forecasting that assumes that a movement of systems tends to be in a straight line or linear. In other words, path speed and direction of movement can be applied to the forecast. And these are most useful for short range forecasts of things like movement of thunderstorms, tornadoes, or so forth. Then there's analog forecasting that depends on a comparison with similar situations in the past, or so-called analogs, or previously called analogy forecasting. And again, this is more pattern-based. Its accuracy depends on really the experience of the forecaster, and you basically use it to adjust the shorter range numerical forecasts. Then we get to numerical forecasting. Here, observations are interpolated onto a three-dimensional grid of model data that we'll be showing in the next slide. And equations are used with being in linear form for short time steps or periods. And then in a computer, the process is repeated over and over as many times as needed. Accuracy is dependent on a number of factors, including the density, the precision, and the accuracy of the observations. Also, how far the grid's spaced apart, how far is the length of time for each of the steps, and so forth. And again, assumptions are made in the linearization, or the making the equations essentially proportional. Now, there's something that's called chaos theory that will put an upper limit on the accuracy for longer forecast periods. And chaos theory is rather interesting, and you may have heard it talked about in the past as the so-called butterfly effect. And basically, it posits that just small differences in initial forecast conditions can lead to different forecasts, in fact, potentially very different forecasts as time goes on. And this is because systems like the weather are chaotic, and here chaotic means they appear to become almost random and having increasing uncertainty in the forecast as time increases, and it goes up very steeply. So this is something that was actually very interestingly pioneered at MIT by Professor Lawrence, who was doing some of the very early computer work in numerical forecasting, and he went off to have a cup of coffee, and he made some observations that even though there were just small changes in some of the initial conditions, he got very different forecasts because he came back to letting the system run for a long period of time rather than a short period of time. So this shows the grid, and it's sort of like a shell over the surface of the Earth. And there is a horizontal grid that's superimposed based on latitude and longitude. So for your X and Y, and then there's a Z or vertical grid for height or pressure equivalent in terms of millibars. And then within each of these, there's a model that's based on various physical processes that include assumptions about precipitation, whether it be snow or rain, momentum or movement, heat transfer, advection, water vapor, sea ice, effects of solar radiation, and so forth. This shows an example of how weather observations all over the world get put through the system. Now, this is a very idealized picture. It starts out with all different types of weather observations. These process-wise have to be quality controlled and then added to the surface and upper air analyses. The east-west and north-south components of the wind, for example, are calculated, and the software needs to keep track of air entering and or leaving each of the grid boxes. Then this advection, along with other sources and sinks of heat energy, get calculated. The model also has to keep track of water vapor and liquid water, and then all of these processes get repeated in time steps that can vary from about 10 minutes to much longer. And it varies based on the scale of the forecast, whether it's regional, national, or global. And then all of these results are output onto the surface and upper air charts. There are other numerical techniques, and the accuracy of forecasts get improved by ensemble, what is called ensemble forecasting. Here, data is run through models with making small changes or alterations to the inputs. The results are compared, and then judgments are made about the accuracy. Obviously, if a very small difference makes a very large difference in results, the accuracy of the forecast is less than if small differences result in not so large differences in the results. Again, the closer the results compare, the more accurate or better the forecast will be. And large scatter means that there's a lot of potential variability, so you should put less trust into that forecast. There are output statistics that allow known problems with the models to be adjusted, and many past outputs are compared with later analyses. Problem areas are noted and saved in a database, and under similar cases, these corrections are then applied to the output. In terms of examples, this is an example with surface forecast charts. So first note that the green lines outline the areas of expected precipitation. The various symbols represent different types of precipitation. For example, dots are rain, asterisks are snow, triangles are showers. The sort of grouped pattern off the coast of Southern California that, if you have a good imagination, sort of forms in the shape of an R, represents a large thunderstorm. Much like there's a chart 1 for marine navigation, there's a complete list of weather symbols, and this can be found on the NOAA website. And it's also partially reproduced in Appendix B of your study guide. Now, typically, short-term forecasts out to about 2 days also include areas and types of precipitation. Longer range forecasts include only pressure fronts and often temperatures. And then upper air charts will also include isotherms at all levels and isotachs at even higher levels. Again, here, this particular surface chart is at 12 hours, surface prognosis for 0 Zulu on the 17th of December, 2014. And it's showing various forms, including the fronts, the isobars, pressure centers, highs and lows that we previously described for this short range forecast. And then there's a longer range forecasts available without showing precipitation. Here's a comparison now between the analysis at the time of forecast on the right with the 12-hour forecast on the left. And this basically shows a lot of similarity between the forecast on the left and what the actual analysis ended up being on the right. So this is, pretty accurate short term. Now this goes on to compare the longer forecast at 24 hours on the left and at 48 hours on the right. And note that the 48-hour forecast doesn't include precipitation. Also at 24 hours, interestingly, those 3 lows in the surface analysis are converging. Here we have now some more comparison between the forecast for 48 hours with the actual analysis at 48 hours on the right. Although because of the different scales, it's a little bit more difficult to compare them than what we saw on the previous slide. It's still reasonably good. The forecasts, or in this case, called prognostic charts, are generally pretty good because they're looking at the large picture. Local forecasts generally wouldn't be as good because variations in the prognoses can mean, for example, that the precipitation is earlier or later or occurs in a somewhat different area. Here we have an example of what are called quantitative precipitation forecasts. And these forecast the total precipitation over a specific time period. The first one on the left is showing 24 hours from the observations and up to a day later. On the right, the 6-hour chart has totals from the observation time to 6 hours later. Here's an example of a chart that's associated with marine forecasts. So here it's showing a 12-hour wave direction and period forecast for 0 GMT or Zulu on that 17th of December, 2014. The arrows are showing the direction of the dominant waves. There's a color scale that depicts the dominant wave period on the lower right. And there are many other different types of marine forecasts that are available at the NOAA website. But I think what a lot of people just end up using for patrols, and again, this is an added slide that I just put on today showing today's National Weather Service forecast for the area that I'm in the San Francisco Bay area. You can see that this is essentially a text forecast that summarizes a lot of features that if you were to go to links that are available at the bottom of the web page, you could go to and look at those various charts yourselves. But here again, it's summarizing a weak surface high pressure system will remain located off the offshore waters, while a surface thermal low pressure trough remain stationary over interior California. Thus, northwesterly winds will continue across the coastal waters while westerly winds prevail across the bays, strongest each afternoon and evening, and moderate period mixed seas prevails through the week. Then it, at a particular buoy station for the waters off Point Arena to Point Reyes, shows that there's a small craft advisory in effect. And then it provides a general forecast at the bottom for tonight, tomorrow, and then for several more days on the actual website that is cut off in the screenshot, with tonight showing northwest winds of 15 to 25 knots, gusting up to 30, wind waves 4 to 6 feet, mixed well from the west at 3 to 4 feet at a period of 11 seconds, and south at 2 to 3 feet at a period of 16 seconds, as well as areas of fog. You can find these and other products at the NOAA website. There are a number of different centers: the Weather Prediction Center, the Ocean Prediction Center, a Storm Prediction Center, and I think what most people have heard of, the National Hurricane Center. A lot of other sites that are a little bit less technical that you may find are more suitable for you. A lot of smartphone apps are available for radar as well as prediction, whether it be one that I like is Weather Underground, but it's less technical, and there are others. You can get an update from home or from your controlling station if out on patrol, and you can also listen to one of the WX channels on your VHF, or you can get text if you have a smartphone at the URL that's shown. So just to summarize, surface analyses are produced every 3 hours, available in a variety of formats. You can get overlays of radar or satellite data. Radar data is obtained from the NextRed Doppler radars. There are a large number of locations in the contiguous United States. These show motion toward or away from the radar based on the Doppler effect. Again, these can be available for either a single station or mosaics of multiple stations, whether they're regional or on a national level. These can see precipitation clouds and on the slow scan air turbulence. Then there are the satellite data that are available from the different types of satellites. The GOES geosynchronous satellites with GOES east and west at a high height of 36,000 kilometers, and then the polar sun synchronous satellites at a lower orbit. Interestingly, this is showing 360, and I recall it was at a different height earlier, so we'll need to check on that to see which one is proper. Then the satellite images are available at different wave bands that include visible, long and short infrared 1 and 2, as well as the water vapor band that represents the total for the atmosphere. Then there are upper air analysis charts that are available less frequently every 12 hours. And these are at different pressures, which correspond essentially with heights at 1,000, 850, 700, 500, 300, and 200. Although sometimes you can find them for 100 millibars. These again show lines of same height, lines of same temperature, and particularly useful for things like on the 300 millibar for a jet stream lines of same speed or isotax. The 500 millibar chart is best for tracking storms because you can see convergence and divergence as well as cold and warm advection. And again, the 300 millibar chart is best for things like jet stream and position. We talked a little bit about forecasting methods, and these include persistence, trend, analog, and numerical. And numerical trends can be improved by using ensemble forecasting and models that have output statistics. The forecast types include surface and upper air prognoses. There are quantitative precipitation forecasts, marine forecasts, and also many others. Lastly, although not a topic for this course, machine learning and AI, of course, no doubt, are being applied to improve weather forecasting. There's a lot of interest in this, and it may help, too soon to tell, but it may help with some of the limitations of sort of the deterministic models that are currently being used, because it sort of uses the data that's out there, and the more and more data, the better it becomes. And so look forward to seeing what that may reveal over time. So we'll stop there and go on to look at some of the questions. The first question is, surface analyses are produced on what schedule? Any volunteers?
Every 3 hours, starting at 0 Zulu.
Perfect. Okay. Next, current weather radars are based on what physical principle?
Doppler.
Doppler effect. Okay. Polar orbiting weather satellites are in what kind of orbit?
Sun synchronous.
Sun synchronous, as opposed to the next question, geostationary. And geostationary weather satellites are in what kind of orbit?
And
Yeah, they're
Equatorial.
equatorial, and they're over a constant longitude. Okay. So, for example, we saw 75 degrees west, 105 degrees west, and for the spare, and then the goes west is at 135 degrees west, located between over Canada, essentially over Canada or water between the continental United States and Alaska. NexRad Doppler radar was developed by who?
Department of Transportation, Department of Commerce, and Department of Defense. Thank you.
Yeah, all the departments of. Okay. So that's probably makes it an easy test question to pick out. All right. The GOES satellite band produces images in what wavelength bands? We talked about 4. It sounds like 3, but one of them is divided.
Visible, infrared, thermal, and water vapor.
Okay, so we have visible, infrared, which is thermal, and water vapor. But remember, also infrared, if they ask you for a number, there are 4, because there's infrared 1 and infrared 2, depending on what you're talking about, short or long wavelength. Then the primary GOES weather satellites are located at what longitude? We already talked about that. 75 and 135, and then the spare is located roughly in between at 105. Then cloud temperatures are measured by weather satellites in what wavelength band?
Infrared band.
Long wavelength infrared, yes. And the visible band on weather satellites operates by reflected light. And the water vapor band on weather satellites operates over what altitude? Yeah, over the entire depth. This is sort of a trick question. Over the entire depth of the atmosphere. It's not just one. Upper air charts are produced how often?
Every 12 hours.
Right, every 12 hours, regularly starting at the new day in Zulu or Greenwich Mean Time. And Persistence forecasting is useful when,
Weather doesn't change.
yep, in areas weather doesn't change very much. Arizona, New Mexico, even San Diego, wouldn't work very well in the Northeast. Trend forecasting is useful in what type of situation?
Tornado.
Yeah, short range, particularly when you have severe weather systems like thunderstorms. And analog forecasting is currently useful when?
When you're correcting a forecast.
Yep, correcting numerical forecasts. And finally, if forecast inputs are altered slightly and rerun a whole bunch of times, what do we call that?
Ensemble.
Ensemble. Yes, you have like an ensemble of forecasts. Okay. Well, are there any questions? And if not, we can turn it over to your final lecture for the course for chapter 8. Here's a little preview. It looks like they're showing a wind chill chart here. If not, thank you so much for your attention. And it's been a pleasure being able to present the earlier chapter as well as chapter 7. Thank you.
Good job. Thanks, Arnold. All right, team. We're going to run through the review questions real quick. Some of those Arnold already touched base on, and then take a quick break, and then we'll be back with Samantha. So if you guys are down with it, we're going to run around the room and ask some questions. Number one, Dave McCullum, surface analysis are produced. You got to unmute, Dave. You there, Dave? I don't know if Dave can unmute. Ed Hallen, how about number one? Surface analyses are produced. Where'd Ed go?
I can go.
You there, Ed?
I had
This is
trouble unmuting. The answer to number 1 is B, every 3 hours.
Right on. Good. Joseph L, number 2, weather radar data are available.
All the above.
Right on. Bill Luckshaw, number 3, current weather radars are.
Effect.
Correct. C, based on the Doppler effect. Pat Mussman, number 4, weather satellites are.
Both B and C.
Right on. Number 5, Richard Clements, polar orbiting weather satellites.
Would be B.
Sun sickness. Jeff Link, NOAA uses the following polar orbiting satellites. This is a hard one. You got to remember a bunch of initials here.
Yeah, I believe that is C. And I don't know if I have all these acronyms right, but METOP, DMSP, and NOAA.
Yeah, good. Correct. Chris McNamara, how about 7? NOAA uses the following geostationary satellites.
D, GOES and Metasat.
Correct. Mike, number 8, the NEXRAD Doppler weather radar. Mike Patina, the NEXRAD Doppler weather radar was developed by.
Department of Defense, DOT and DOC. C.
Right on. Yeah, Arnold did a nice job explaining this. Somebody had a question during the class about, do airplanes disrupt the weather radar? And they're done on different bands. So there is radar used to track airplanes, but for purposes of the weather radar, it's not going to conflict. Jock Oilsley, how about number 9? NEXRAD Doppler radars can detect.
All of the above: precipitation, clouds, and turbulence.
100% correct. Good. Jennifer, number 10, the GOES satellite produces images in the following wave bands.
Visible, infrared, and water vapor.
Good. Now, somebody had a question during the class about why is the temperature, the cloud top temperature, important, and that has to do with how high the storms are. So if you have an area of weather and right in the bullseye center of it, the temperatures are very cold, that's an indication that storm is like a cumulonimbus that is shot way up in the stratosphere. Jack Benton, how about 11? The primary GOES satellites are located at longitudes.
75 west and 135 west.
Good. 12, John Zills. Cloud temperatures are measured by weather satellites in the
Infrared bands.
correct. Dave Bobos, 13, the visible band on weather satellites operates on.
A.
Reflected light.
Reflected
correct.
light.
Mhm. Stephen Boyer, the water vapor band on weather satellites measures moisture.
Oops.
What's that?
You're talking about 13, aren't you?
13, no, 14.
Oh, 14, my bad. Water vapor band satellite. Oh, okay, that is over the entire depth of the atmosphere.
Yeah, that was the one that Arnold was telling us was a trick question, so watch out for that one. Addison Chapman, how about 15? Upper air analysis charts are produced.
Twice a day, C.
Correct.
Yeah, so sorry, Bob, just to go back, the way 14 is worded is not a trick question, but the way it was worded in the questions at the end of the presentation, where it asked at what altitude, suggesting it was at only at a particular altitude, was the one that was the trick way of wording it as a trick question. So I don't know which will end up being on their final.
Excellent. James, did I ask you that question? I'm trying to remember where I left off. Did I ask you that, James, or did I skip around here? All right. How about Oliver, number 16, I think we're on. Persistence forecasting is useful for. You there, Oliver?
Sorry, I was muted. That would be B, areas where the weather does not change much.
Good. Arnold explained this in terms of like desert areas. That was very good. Angela, trend forecasting is number 17. Trend forecasting is useful for.
C.
Good.
Forecast position of tornado.
Yeah. Tornadoes or thunderstorms. Bob Mack, 18. Analog forecasting is most useful for. You there, Bob?
There it goes. Sorry, in my mute button.
No worries. What's the answer? Did you get the answer right there?
Yeah, number C.
C is
Letter
correct.
C.
Correcting numerical forecasts. Bill
Correct.
Madison, 19. Numerical forecasting makes use of.
Both A and B, surface observations and upper air.
Which is choice number D. That's 100% correct. Dave Watkins, 20. Ensemble forecasting is. You there, Dave? Noah, how about ensemble forecasting? You want to take a shot at that one? You there, Noah? Go ahead, unmute yourself, Noah. Oh, you can touch your space bar. That'll unmute you. Thanks, Bill. Appreciate it. Jeff Link, how about number 20? Ensemble forecasting is?
I believe in this case, it's D, none of the above.
Yeah, I looked real hard at A because we talked about different models, but it's really not a large number of computers. So that's how I think that D is the correct answer. Mike
Yeah.
Bettina, 21. Smartphones can be used to obtain?
All of the above.
All of the above. Good. All right, team, we're going to take a quick break here. Is that fair, Samantha? Can we get a quick break in here, about 10 minutes?
Sure. And just remember, since I've had slide issues, you're going to have to share your screen and scroll through for me.
All right. Now, you want me to try to let you share? You got some bandwidth issues there.
No, I can't get the slides to unlock for me to use on a slideshow other than viewing it from the website. So
that's not a problem. Arnold, can you do that? Do you already have them up type thing?
I can help out if in the next 5 minutes, I'm able to download it. So why don't people take their break? I will work on downloading chapter 8 to see if I can project that.
All right, folks, we'll see you at how about 8 minutes after? See you at 8 after. And you can hang around here in case you got any questions. Dave, sorry to hear about your microphone. We'll see you back here at 8 after, everyone. Give us a second to get the computers all squared away. Almost at the last chapter. Almost done, team. Good on you. Robert, anything, Rob Kumpf, anything you want to share with us privately here while everybody else is on break? You there, Rob?
Yeah, I'm here. No, I was just popping in to see how it was going.
Well, you're very welcome, sir. We got one chapter to go.
Close to the end, so
What was that?
I thought we'd be pretty close to the end here, so I figured I'd pop in.
Appreciate it. Yeah, no, this is a ton of work, and it's we had a number of students that already taken this class, and they signed up to take it as a refresher. But it's a lot of work. Some of those people haven't come back after the 4th and 5th chapter because that was pretty intimidating. But we've got a
It
good
is
crew
hard
here tonight.
work. It was not my favorite course, I can tell you that one.
Let me see. You know, since we're taking a break here, I'm going to see how long it takes me to bring up mine too. So Arnold, I'm planning on using you, and I'm going to fool around here for a couple minutes, see if I can't bring them up too.
Yeah, so I'm having to log on to Moodle to be able to do that. So don't 100% depend on me. It will take me a little bit to log on to that.
So what I'm going to do then is 100% depend on you, because it turns out I can't, well, maybe I can shrink it, but it's when you're doing the recording, it's harder for me to get at them than it might be for you, but I'm not sure about that. We'll see.
All right, let me see if I can.
See if I can figure out something.
Sorry, guys, I think it's a Mac issue. For whatever reason, this class won't save to my Google Drive like other ones will.
All right, Arnold, I think I got it figured out. I'm not sure if I can do it simultaneously. Are you close or not really?
I am not there yet.
If you'd like, I can work on my end to make it happen, or do you want to work on your end?
Why don't you work on your end until I'm able to, I'm looking at Google Slides right now for this, but it is on my iPad and it is not yet transferable to my computer to share.
All right, I'm here. I think I can do it. Let's see. How does that look? Can you see me now?
Yes, I can.
All right, Samantha, how's that? Look pretty good?
Yep, that's fine.
All right, I'm gonna be quiet and I guess we can stay here and visit. Pat, how you doing? Pat Musman?
I'm doing good, Bob. I have a message from JT. She's running late tonight. They had something going on at a city council meeting.
I think she was doing something with National Boating Safety Week. What are those called? Proclamation. So,
Right.
so good on her that she's doing that, and she let me know. I appreciate that. I had Gene Velez let me know that they're doing something with the flight. I'm wondering if it's a search and rescue flight, so I'm kind of curious, but he said he was going to be late if he could make it at all. But,
Yeah, I'm going to the city council meetings tomorrow night and Thursday.
How loud? Can you hear loud noise in the background? Should I unplug the refrigerator? I wonder. Is that really loud in the background, Pat? The sound of the refrigerator? Because I can mute myself.
No, you're fine.
It doesn't sound bad at all, Bob. Sound pretty cool.
I was at my flotilla meeting, and I think it's over now. But I volunteered to cook brats and burgers for our party on June 3rd. You guys are in the Chicago area, you want to do some vessel exams or come hang out, you're welcome to come meet us over at the Burnham Harbor boat ramp area. Should be fun.
So let me see if I can now project this before you get started, in which case then you would be freed up for being able to do the recording.
All right.
Would that work for you?
Yeah, give it a shot here if you don't mind hanging out and doing that.
Yeah, no worries. Although it's possible that family members may come in not realizing I'm still online at this time. But in any case, all right, now. Okay.
Thursday, the two of you looking for it forever.
Let me know when you can see the screen.
I can see the screen just fine.
Does that sound okay, Samantha? I'll be here so that way I can watch the chat. And you got a nice compliment from Joseph Ladino. Arnold, thanking you for doing your presentation.
Oh,
I'm gonna mute myself. What time you got? Oh, we got a couple more minutes.
Yeah, and apologies for the persistent caller. I apologize for not having turned my phone off before.
I think everybody was okay with that. We had the flotilla meeting, which is a Zoom I was doing on my phone in the background here. We had the flotilla commander's phone rang on him, which was kind of a shock, I think.
Yep. Unfortunately, having patient responsibilities, I'm used to never turning my phone off. All right, whenever you want to get started.
Is it 8 after? I promised people we'd go 8 after, so it might be another minute.
We have 2 minutes.
A minute and, yeah, 2 minutes.
So Gene Velez says they're working a flight from Jacksonville to Nashville. He's in Jacksonville. I wonder if that's a Coast Guard auxiliary deal. I used to fly with the Coast Guard auxiliary here, but I'm not flying these days. Jennifer says, Arnold, you're the good doctor. We will have a flotilla leadership class in Chicago, in case anybody's looking for a flotilla leadership class, coming up on June 11th and 18th. So those are going to be Sunday afternoons. For those of you that are not too far from Chicago, we don't have any approval to pay for transportation for folks that come from far away, but we're excited to be doing a foothill leadership class. Got a lot of change happening in the auxiliary. Some longtime leaders are done with their 2 years, and so we need more young people to step up to the plate. Yeah, Jennifer's going to be there. Did you already let Bob Oculek know, Jennifer? You could unmute if you want to.
Yes, I sure did. I registered for the class on the Google document and I have the confirmation that I'm registered. I just don't have a whole lot of other details after that, but that's okay because I know I will get the details when they're available.
Yeah, these days, some of these activities we used to do annually, and we haven't done them in a few years, so it's almost a surprise we're able to put them together.
Yeah, and it seems like it's all hands on deck with the auxiliary because it's May 15th, the boats are going in the water, and National Boat Safety Week, and so I know everybody's very busy.
All right,
Hey,
guys.
Very
We're
good.
at 9 after, so let's go ahead and get started. All right, so this is chapter 8, what we've all been waiting for. Drum roll, the last of this class. So we're going to talk about preparing for and executing a mission. Next slide, please. So, as every other chapter, we are going to use the following view graphs as a guide for discussion. Discussion is really the key for this chapter. Like, I can lecture you, but I would like you to be able to ask your real world questions while we are all here and talking about weather, because we're all located around, the US in different areas. And so something that may pertain to me in the Midwest or when I'm at sea is completely different if you're in a coastal region or you're working on a river instead of a lake, or you're flying instead of being operational on a boat. So please bring up your questions and discussions during this chapter. Next slide. We're going to talk about using weather information for mission planning and execution. We're going to discuss restrictions to visibility. We're going to talk about thunderstorms and lightning, which I am tired of after the past couple of weeks here in the Midwest. Wind and waves, hot weather issues, cold weather issues, cold water immersion, tornadoes and waterspouts, and hurricanes. Planning a mission. So in an ideal situation, you putting in your orders a couple weeks out to go out on a patrol. So as the patrol comes up and gets closer, start preparing 2 to 3 days prior to see what the weather is going to do. What's the forecast saying, and how is that going to relate to you? Day of, again, check the weather. What's the winds? What's the temperature? What's the humidity? What's the clouds like? Do you have all the gear that you need for the weather and the conditions that you're going out in? Making sure your crew is taken care of. Are you going to have fog, rain, snow? Here in the Midwest, we can go out on a beautiful afternoon and there's not a drop of rain expected, and then we get these pop-up thunderstorms, which for us is when we call it a lunch break, and then we'll go park at a restaurant on the lake and have lunch and wait for the storm to pass, and 30 minutes later you can hit the water again, or an hour, or whatever it is. So know the weather around you, know what to prepare for. Look at your satellite data and radar. There's a phone app that I use, Radar US Plus, and it's a $1.99 subscription when I bought it 13 years ago, but it's updated with every single iPhone upgrade. That's what I personally use. I like it quite a bit. So that's using your smartphone as a device to look at weather. Yeah, monitor your conditions when you're out on the water or you're flying. Stuff can change quite often. And then before you should get on the water, part of your GAR is making sure that all of the conditions are safe for what you're going out for. Next slide, please. Things to consider: fog, heavy precipitation, thunderstorms and lightning, winds and seas, air temperature. So you can have hypothermia and hypothermia. And then again, what does that mean for your GAR? So winds and seas are fun. On the Polar Star, I think they just posted them to let us know how miserable the day was going to be sometimes. So but it's important to know the capabilities of your vessel, your crew, and also your coxswain. So you may be able to go out in different conditions with different crews, or a different vessel. And so you have to keep that in mind on your patrol too. So make sure that you are aware of your equipment, how to use it, and what situations you are comfortable using it in. That's something I see get overlooked sometimes, that, oh, I can do this, I've done it before. Well, if it's a completely different, vessel to you, or new crew members, you may not be able to do those things that you've done before. So you should never risk your crew. Keep that in mind. Next slide, please. Restrictions to visibility. So fog is not a big thing here in the Midwest, but you can definitely get a lot of fog in the coastal areas and other places, and heavy precipitation can reduce your visibility to dangerous levels. What I'm going to say, I disagree with one of the questions that we'll have at the end of this chapter. When your visibility goes down, before we try to shoot an azimuth and get a bearing on how to get to safe harbor, we need to make sure we're immediately safe and slowing down, stowing gear, ahead of time. So we want to make sure that we're traveling at a safe rate of speed. Radars help some, but again, it depends on what platform you're using. And the boats we use out here don't have radar on them. If you're on a coastal area, ships and larger vessels are going to have radar, but they can't see flat items very well. Down in Antarctica, we could see ice on the radar, but again, that's only the surface ice, not what's underneath. So we also relied a lot on our lookouts so that we were giving enough leeway between the ice and where we were going, because the captain did not like to hear ice hitting his vessel if he was not planning for us to be hitting and running into ice. So even with radar, you can't see all dangers that lurk ahead. If no one's charting a plot, if no one is a chart plotter, sorry, I said that backwards, you will need to plot your positions on paper. So even active duty Coast Guard uses both paper charting and electronic charting. So there's a saying that 1 is none and 2 is 1. And I like that and I agree with it, because if something fails, you need to have a backup. So if your GPS fails in this instance, you'll need to know what compass course to steer towards your destination. And having someone plot where you're at on a chart, so you know where where you're going and how you can get back there. Have deviation tables for normal operations. So for loss of electronics, different electronics can interfere with your compass, certain metals can. So you want to make sure that you know what the deviation table is on the chart that you're using. I thought I had a map sitting right here. But generally it's going to be in the key, or there'll be a symbol up top that shows a compass and shows you what that deviation is from magnetic north and true north and stuff. So you're going to want to know how to utilize your tools. So just because the boat has a compass doesn't help you if you don't know how to use it. So that's something else to practice and have drills with your crew, of making sure everyone knows how to use the items on the vessel. Next, please.
And Samantha, we had a question about what a GAR score is from a newer member. Could you briefly touch base on that? Explain what a GAR is?
technically the GAR score doesn't exist anymore. It's turned into something else. So basically a GAR is like a risk assessment to see if you're going to go out or you're not going to go out. So if there are too many factors in, say, the red, meaning there's too many risks for the gain that we're going to get, we're not going to go out on, say, just a general maritime patrol. Now, if we're going out on a search and rescue, or there's a vessel in distress, we're going to weigh that score on the outcome of if we think we can go out and not get an injury or damage our vessel or something like that while rendering assistance to the others. So it's a model that we use in the auxiliary to see if it's a go or a no-go for a mission. And they utilize it in active duty as well. There were days where we couldn't do small boat operations in Antarctica because of weather. It might have been sunny and beautiful, but it was blowing too hard to lower the small boat. And the NOAA scientists were really irritated about that because they wanted to get in the water and do their charting for what they were doing. But safety comes first, and the active duty is no different. If it's not safe and we're not going to operate outside of those limits, it's just so a scientist can put something in the water and ride around. So if it was a man overboard, that would be different. You would take more risk or accept more risk because the outcome is a person's life versus a piece of data. Does that make sense, everyone?
It does. We're going to have, at the end of this, we'll have Rob explain what the peace model is.
Great. I'm not a boat crew certified person, so, and I've probably should know peace, but I've only heard it once, and yeah, something for me to work on. All right, don't patrol during severe thunderstorms. I feel this should be a part of the discussion part. So why shouldn't we patrol during severe thunderstorm watches? Okay, it could be dangerous. So we have watches and we have warnings, like we read in our book here. So we are going to negate and be on the safe side in any sort of inclement weather. So during a thunderstorm watch, we're not going to want to go out and take the risk to ourselves. So if it's likely that you should not go out, then don't go out. So this is talking about that risk. So if it's relatively safe, keep an eye out, look for developing storms. Like I said, here in the Midwest, it can be a perfect day and then a thunderstorm pops up for 30 minutes and goes away. You can be down in Florida and you can have a thunderstorm at the same time every day. So some of that is going to be knowledge to the area that you're used to operating in as well. So it's these air mass thunderstorms that I'm talking about that pop up quickly. And the way that the lake, we don't have true lakes in Missouri. They're all reservoirs that have been, man-made, and they flooded the river basically. So the way these reservoirs sit, they're low. And so our view is obstructed. So by the time we can see a storm approaching, it's generally time to get off the water and wait for it to pass. So that's something that we know from being in this area, whereas you can be out on the ocean and you can see for miles that a storm is approaching. So just be alert to your surroundings. If you do patrol, stay current with the developments. So I use my smartphone app. So when we're having lunch, I'll pull it up. I'll see what the weather is going to do. You're on your maritime radio, you have the weather channel. So if you have a multifunction, you can monitor 16 and the weather station. So that's kind of nice. Or you can have someone else monitoring a weather station if you have two vessels involved in the patrol. So there's a lot of different ways to work it. It also says you can have a friend or family member contact you via phone. And again, that's a no-no if you're the coxswain or you're the helmsman. So we're not supposed to be on our phones when we're on patrol, but you could have your radio guard radio you and have them watch the weather, which has happened before when we've been out on patrol on the lakes, not seeing the storms coming in. You know, the radio guard lets us know that there's a storm popping up, and then we'll decide to take our lunch break then. Next slide. If you can't avoid a thunderstorm, take the following actions. So determine the course to a safe harbor. So it may not be where you put in, but for example, we have various restaurants and marinas and stuff around our lakes that we can go to. So we just want to take shelter in safe harbor. If we can, maybe safe harbor is getting behind an island so that there's something blocking the waves for us. So that's something, you know, that I've had to do before out fishing of, well, I can't get back to a marina, but I can go over to this cove where I'm out of the wind, so the wave height's not as bad, and, you know, wait it out behind a little island. Stow all your loose gear, note the wind direction, because you can tell how close the storm is. So is the wind blowing towards the storm, or is that microburst right near you and now it's going away from the storm? What's the temperature in the air like? Is it hot and then suddenly cold? You know, what's happening? Try to move perpendicular with the storm so you're not going into it. You're not going to outrun it on the water, so you can go perpendicular. When close, turn into the gust. So that's important. So you don't want to swamp your boat and get broadsided by wind either. So you can turn into the gust and then hit those waves at, you know, 45-degree angle so that you're not burying the bow of the boat. Try to say that one 3 times fast when you're hitting that next wave. So you want to ride it out in a safe manner. Thunder or lightning, turn off all electronics, lower your antenna if possible, stay away from metal objects. And it says communicate via cell phone if possible. So there's probably that exception to the rule for that, since it's safer to communicate that way. Next slide, please. Small craft advisory issued under the conditions that vary by the region. So what are they in your area? So a small craft advisory that we might have here on one of our lakes is a lot different than the small craft advisories that you're going to see in coastal regions. So that Point Reyes, Point Arnes, small craft advisory that's going on there, you know, near Bodega Bay, those vessels would be considered large vessels here instead of small vessels, but they're, for the size boats they are, for the fishing and crabbing that they do, that's their small craft. So it's going to vary area to area. So know what that means to you and your crew and the vessel you're taking out. Gale warnings are issued. What's important to know is the key number 34 knots. So gale force winds are fun and exciting if you're in the correct vessel, but for our purpose in the auxiliary, you know, you're probably going to want to get off the water in inland situations, because that's a pretty bad storm if we're getting gale force winds. Wind wave height is determined by sustained wind speed, the duration of the wind, and the fetch. So that's the distance the water has traveled over, or the winds traveled over the water. So we'll get white caps even here on the lake, and you know, we're going to want to be aware of, again, how that affects our vessel. So my cabin cruiser It can be, I can have white caps out, it can be windy. It's not really gonna bother, you know, a 26-foot vessel like that. Now, my bass boat, on the other hand, if it's choppy with white caps out and windy, that thing's gonna be bouncing all over the place, and I'm not gonna wanna be out in that. So again, pay attention to the wave height and how that's impacted by the wind. The waves are also influenced by the average depth of water. So that's why we get waves, you know, developing and coming up to a crest and a peak and crashing down when we get to the shore versus that happening out in the middle of the ocean. So generally it'll move along, hit something that's more shallow, force that water up into that crest, then it's going to peak and come over in a wave. So just because it doesn't have a break doesn't necessarily mean it's not a wave. So steepest waves when the wind blows against the current, again, because that's pushing against that, allowing the face or the wall of that wave to build. You can watch your buoys. If we don't have buoys here that we pay attention to, but again, in your ocean areas, you're going to see that. I used to watch the buoys all the time to get a surfing forecast when I lived in the San Francisco area. So that was really important for me. So pay attention to what those wave heights are doing. And so besides getting the wave height, you're also getting the interval between waves, because that's important too, to know. That's one of the things about issuing a small craft advisory or not. The waves are too close together, you're going to have some major issues if you're a small vessel. If you're a 100-foot vessel, you're not going to have those issues. So wave forecasts are given in heights of 3 to 5 foot. Yes, it just covers the likely range. So you'll see, you know, down in the Southern Ocean, it was great. It was like seas, 20-foot intervals, whatever, however many seconds. And so that was like the average wave. And then it was not uncommon in the Southern Ocean that you can get hit with like a 50-foot wave that just comes up out of nowhere. So super fun to sail in. I highly recommend the Southern Ocean if you're an adrenaline junkie like me. So next slide. All right, warm weather issues. So I didn't experience warm weather issues like I did until I moved to the Midwest. So dry heat, I'm just happy as a clam. Now you move here to the Midwest and we're no longer cooling ourselves when we're sweating and we have high humidity because you're just staying like saturated all the time. So that sweat's not evaporating. I feel overheated and sticky and like you can't drink enough water here. So it just can lead to heat exhaustion, heat stroke. You can get that too when you don't have humidity. I just have noticed that those heat and humidity elevate those warm weather issues. So know your heat index. We have a slide on that. I would recommend taking a PDF copy of that, keeping it on your phone. So that's something that you can look at when you're going to go out on patrol of what is the weather, you know, like what is the heat index? How is that going to impact your crew? So, you know, if I know Bob has issue A or whatever, and Susie has B, how is the weather going to affect that? And then maybe we'll do a morning patrol or an evening patrol or even a night patrol instead of going out in the heat of the day. So we're going to want to hit areas where there's still, you know, an objective to what we're doing. But I can take the weather into account with my crew and how we're going out. Also the type of clothing that we're going to wear. You know, maybe it's something where a hot weather uniform would be able, you know, to be approved. so that we are cooler. You know, maybe we can have shorts on with sunscreen, and maybe we can take our blouses off. When you're on an active duty component, I can guarantee you the only time that we wear these ODU tops, blouses, is if we go to quarters, or if we're docked up somewhere. Otherwise, no, it's hot in the ship and everyone's just got their blue shirts on and their ODU pants. So you got to keep your crew cool, because when we were in the doldrums, very hot, very humid, and the ocean temperature was like 90 degrees. So be aware of what that's going to do to your crew. Next slide, please. So this is the heat index chart I was talking about, of downloading this, taking a picture, keeping it on your phone so that when you are preparing to go out for a mission, that you can see what the heat index is going to be with the relative humidity. So this week, it's been in the 80s here in Missouri. Oh, you can't see my mouse anyway, but if we go over here to what our, if it's 80 and we had an 80% humidity, the heat index is 86. Next week, when it's in the 90s and we're that humid again, it's going to seem like it's 113. So you want to pay attention to that, and when you're out, when you're not, making sure that your crew is properly hydrated. So red is extreme danger, orange is danger, a lighter orange is extreme caution, and like a dark yellow is just fatigue. So that's going to impact how long your crew can work for before needing to take breaks. So for example, the kitchen gets really hot on ships, and so we would have to monitor the kitchen and the dishwashing area, or the scullery. And when it reached temperatures of 105 in there, we were forced to take, I think, like a 10-minute break for every 30 minutes that we worked. So it's important to make sure you're taking enough breaks and drinking enough water and staying hydrated and caring for your crew. So you don't want someone to have heat stroke. They could die from that. Next slide, please. Cold weather issues. So you're going to want to have a underlayers, layer up in cold weather. So still air, the body warms, a shallow layer around you. It also even happens in the water. So when you're like in the help position in cold water, the water around your body is going to warm up a little bit. So it's kind of the same with clothing. You have a barrier there, so that air is a lot warmer than if it didn't have something over it. So have your base layer or boundary layer next to your skin that's going to be under your clothing. Increased wind speeds, remove that protective layer and increase the rate of heat loss. So you're going to want to have proper clothing. Our parkas are pretty nice with blocking the wind. So in Antarctica, when it was windy, I would wear my Coast Guard parka instead of the Arctic gear that they would give us, because the Arctic gear was not Antarctic gear. And so while it was very warm, if you didn't have a wind resistant or windproof layer over top of that, the wind would just bite right through it. So it's important to have those protective layers on so that you're not losing heat through that wind cutting through you. The rate of which the exposed body part is going to lose heat depends on the temperature and the wind speed. So we want to be aware of that, but frostbite is an issue that we're going to need to be aware of, and getting hypothermia. You can get hypothermia just not even thinking that it's too terribly cold, but you're sitting there long enough that you lose enough body heat that you can start to get chilled. Happens to a lot of folks during deer season. So you got to be aware of the wind chill factor, and also just the ambient temperature and what you're doing. And you also have to account the wind chill from your vessel moving. So what's your rate of speed and what is that wind chill going to do to you? So some people don't think of that when they're out on the water. So depending on what type of windscreen you have, you know, someone might be riding in an area that's pretty chilly on that vessel. So the wind chill temperature table, which is the next slide, I also think that you should have a picture of, so that you can know how to dress. And again, assess that with your GAR or your piece model for your crew. So is that something where you guys need to wear Mustang suits if you're going to go out that day based on the weather? Or can you wear your ODUs and parka and your life vest? Or do you need to do dry suits instead of Mustang suits? So they're expensive, but make sure that you're properly clothed or platted for the environment that you're going to be working in and patrolling in. So frostbite occurs in 15 minutes or less, and it's very painful, and it can cause permanent nerve damage even if you catch it soon. So don't want to mess around with frostbite. All right, next. Tornadoes, waterspouts, and hurricanes. Do not patrol during a tornado watch or a severe thunderstorm watch. So that should seem pretty common. If something comes up, you know, out of the blue, like it does happen sometimes, get off the water. You don't want to be out there during a severe thunderstorm watch. We had one pop up and that was a partial factor into some vessels sinking at a lake here. The way that these storms can come up. So don't be out patrolling during those. It's not worth it to your vessel and your crew and your life. If you encounter a waterspout, travel in the direction perpendicular to its movement. I have not seen them in person, but they can be fascinating and scary from what I've heard people talk about and what I've seen on television and stuff. Do not patrol during a hurricane watch or warning within 36 to 48 hours of landfall. So before the hurricane ever hits landfall, I don't know if you guys have ever heard of storm surges. I mean, probably you have because you read the book. Everyone read the book. So your storm surges are what's going to start causing a lot of flooding and damage early before the hurricane even makes landfall. So it's not safe to be out there. There's a lot of shipping vessels can get in trouble going from Florida to Puerto Rico or Virgin Islands during hurricane season. So they have to pay a lot of attention to their barometer aboard their vessel. Because you know, your weather report can say one thing, but if what you're seeing and what your barometer's saying and your other, you know, wind speed saying isn't adding up, you need to make the call based on what the current data is that you have. So the one American ship that has been lost in the past 20 years or so, they just kept following what NOAA said and thinking they were going to be past the hurricane before it hit them, and they literally collided almost with the eye before their ship sank, despite the pressure dropping, the winds increasing. It was a horrible disaster that the Coast Guard had to investigate, and luckily they got that class of vessel off the waters, because there were others in that class that were older, dilapidated, rust, had design flaws, and so they were no longer in use, making it safer for our American maritime folks to be traveling in. Into the Raging Sea. Yes, that is a really good book. All right, so prepare your facility, top off the fuel, be ready for search and rescue patrols after the hurricane. Protect your facility in whatever way is appropriate for your area, and discuss these with the class for individual actions in your AOR. So, you know, planning ahead, you might have your vessels, you know, trailered out of the water and in a garage or in a storage facility or something like that, so that it doesn't get damaged. So again, we get some hurricane effects here where I'm at in Missouri, but we don't deal with them the way that Florida and the Gulf areas do. So I'm not an expert in that area, but I'm sure you guys have a plan down south of what you do with your vessels. Just like our military will take ships out to sea, so they're not near land, and then we'll fly our aircraft out of certain areas so that we're protecting our assets from the upcoming storm. So you're going to want to protect your assets. Next slide. So know how to use your weather data and plan for patrols. We have a lot of tools at our disposal after taking this class. And one of those most important tools is yourself. So even if you don't have electronics or your phone doesn't work, remember what we've learned. What do the clouds look like? Which direction is the wind coming? How can we find the low from where we're at? What's the water doing? You know, are there ripples on the water? Are there waves increasing? You know, Vikings and several other people sailed long before we had all of this fancy equipment. And so you are your most important asset. Your GPS is not, you are. So know how to navigate, know how to use everything on your vessels, and remember the items and the things that we've been taught in this class. Visibility reduction, slow down. It's not worth speeding up. It's more dangerous to speed up when you can't see. Might be a little scary, but remember when you take, you know, your navigation class, you know, what's our interval for blowing our horn or honking our horn, you know, when we are in limited or restricted visibility. You know, what are we supposed to do there? Don't go out in thunderstorms and lightning. If you do get caught out there, turn off those electronics, stow your gear, make sure your crew's safe. Don't touch metal and don't be the tallest thing on your boat. So don't stand up top like Lieutenant Dan, you know. Pay attention to the winds and the waves around you. What's the water doing? What's the current doing? Are you in the mouth of the river? Are you in the, you know, just know where you're at so you can know where to go, and know the environment that you're operating in, or have someone with you that's an expert on that location. Remember what your cold and warm weather dangers are, hypothermia and hypothermia, and be prepared to deal with those with your crew, as well as people that we might come across that's having an emergency out on the water. Remember what your cold water dangers are, and plan accordingly for the gear that you have aboard, what gear you're wearing out on the patrols that day. Be aware of water spouts. Again, don't drive towards them. Don't go towards the light like Caroline. Go perpendicular to the water spouts. Weather is just one aspect of risk reduction, but it can be very important part under some circumstances. So it's very important. You know, I don't know how to stress it enough. It's important. You have the option of going out or not going out when you are going out on patrol. Active duty has the same thing. What's the risk? What's the benefit? And unless we are under a very strict timeline, even out at sea, we would either slow down or speed up depending on where we were to avoid a storm, because although we will go through whatever's in front of us to get to our final destination, we spent some time just cruising around off the coast of New Zealand to allow a pretty massive storm to pass before we headed through the Southern Ocean to Antarctica. Now, coming home, we had limited fuel, limited food, so we didn't have that luxury to putt around because we'd already spent a month longer than we were supposed to in Antarctica. So there were more storms to go through. So risk benefit is important. So I can't stress that enough. And know how to use your equipment. All of it. That's all I got.
You want to kind of walk through the review here, or do you want me to shake things up and we'll go through it? What would you like, Samantha?
No, I could do this.
I know.
So we can just toss out answers. I won't call on you guys for this one. I'll call on you for the chapter reviews. But while on patrol, visibility unexpectedly becomes restricted. What's the first action you should take?
Slow down.
Yes, slow down. This is going to tell you to take a bearing to safe harbor. Which type of thunderstorm is the most difficult to plan for? Talked about it a lot here in the Midwest. We have
An air mass thunderstorm.
Yep. A thunderstorm's approaching. You should initially proceed in what direction?
Perpendicular to the storm.
Mm-hmm. There are thunderstorms in your area. You see ripples on the water. What does this mean?
Storm was close. And then down press.
Down burst.
Winds blowing toward the storm.
But the storm was
So,
close.
those are all important, but when you see the ripples, those are specific to what kind of burst?
Downbursts.
Downdrift.
Mr. Allen, you
Downdraft.
have the key to for its microburst, I believe.
Right on. Go ahead and click there, Arnold.
So thunderstorm is close, the downdrafts are there, there could be microbursts. All of those are good. Small crafted advisories are issued under what circumstances?
Depends on the area.
Correct. Gale warnings are issued when the winds are expected to be over what speed?
34 knots.
Correct. The heat index is a function of?
Temperature, humidity.
Yes. Wind chill temperature is a function of?
Temperature and wind speed.
Correct. The probability of heat exhaustion and heat stroke increase with?
Temperature, humidity.
Temperature, humidity.
Correct. The probability of hypothermia increases with?
Decreasing temperature, increasing wind speed.
Mm-hmm. Is that it, Arnold, for those pop-up questions? So we'll go through these test questions real quick. There's only 11. All right. What steps are included in using weather for planning a patrol? Jennifer. Bob, Mac, do you know?
All of the above.
Correct. While on patrol, visibility becomes restricted. What steps do you take? Let's see. Bill Madison?
Take a compass bearing on your safe harbor and slow down. D.
Correct. With regards to the thunderstorm, which kind is the most difficult to deal with in a planning phase? Jack?
Yeah, air mass thunderstorms.
Mm-hmm. When a thunderstorm's approaching, you should initially Ed. Joseph.
B, run perpendicular to the direction of the storm movement.
Great, thanks, Ed. Joseph, you can answer 5. What evidence should you watch for that says the effects of a thunderstorm are imminent?
Ripples on the water.
Winds blowing toward the storm, B. I thought it was B.
I think what they're looking at is when it's that close, you'll start to have outflow.
Mm-hmm.
So before, when you're near a thunderstorm, you'll have inflow, which should be the wind, the air is sucking up into the storm. But when it's getting close to you and you're having a downburst from the storm, you'll see the ripples on the water, and that means it's coming down towards you. The outflow is.
Yeah.
Does everybody also feel that the temperature just go down really quickly when you see that too? I've had that. You all of a sudden get cooled by 10 degrees. You feel
I
that.
noticed that too. And there is a pressure drop.
Yeah.
So you can feel the pressure change. At least my experience with tornadoes in the Midwest, there's a little difference. I mean, this isn't a tornado, this is a thunderstorm, but notice those. All right, small craft advisories. We already issued or discussed this one. It varies with the region of the country. A gale warning is issued when winds are exceeding 34 knots. We answered 8 and 9 in the review, and 10 and 11. Okay. So the rest of them we answered in the review, sir. So we are done with chapter 8, and I'm happy to answer any questions about my experience on the ocean or lakes or whatever, to go out and how weather affects things, or radar, or being out works on ships or whatever.
Great job, Samantha. And Arnold too. Thanks, guys. And Arnold, thanks for doing the audio visual. Let's give Samantha a thumbs up. You guys know how to do that on the bottom of the screen there, the reactions. And give a thumbs up. Think of that. Or clapping. Clapping is good.
Yeah.
Great job.
Did you want to see the peace model or any of those things?
We are going to have the Rob touch base on that real quickly. And then I'm going to talk about how to take the test. But before we do that, did anyone have any questions for Samantha? Are there any questions for Samantha? Great job. And you all saw. Go ahead.
Yeah, Samantha, could you give me that that radar app again?
Yes. So it is called Radar US Plus, all one word. And it's super neat. So it'll update where you're at in the Midwest, and you can zoom in or out, but like I'll zoom out, and for where I'm at, basically the weather that we get from Oklahoma rolls up to where I'm at here in Southwest Missouri. So
My display, it got blurred out, Samantha. I don't know. Did anybody else see her display there? She was trying to share with us.
Because I have the background blurry thingy on. That's why. So here we go. Let me turn that off. You guys can see my messy background here. So there we go. So there's really nothing going on here. But yesterday there was. And I mean, I can look at the whole North America. So, and then there's different things that I can pull up that I want to look at on the radar. So the resolution and different charts and stuff. But it used to cost like $1.99, Radar US Plus.
Wonderful. And so what we will do is, we had a question about the GAR score, which is kind of passé. Bill Luckshaw also wanted to share some interesting information about a big storm he witnessed. But Rob Let me see if I can make you co-host. Are you, you want me to share your screen then?
I think if you let me be a co-host, I think I can share it from here because I've got it all pulled up.
Stand by, let me see if I can figure out what I did here. My radar. Joseph, why don't you read that while I figure out how to share screens here?
Sure, no, My Radar is another app that's really, and it's free, I think, and I use that one, which is really good. Predict Wind is excellent, but it's expensive. If anybody's ever used that, and you really see all of the different directions, and it also it predicts, 30 minutes ahead of time what the scenario is going to be. But it is expensive. It's, I think it's over $100 a year. That's a really good one.
Cool. All right, Rob, your co-host.
All right, cool. Give me 1 second to get this up. So when you take intro to risk management, hang on, let me get my, can you guys hear me okay?
Yep, we can hear you loud and clear.
Making sure. I don't have my headset on, which is strange. If you take the risk management TCT course, you'll go through all this, but this is basically over here on this side is the old GAR, which was a 1 through 10. And this just shows you what pieces, which is low, medium, high. So it's all the same stuff. It's just put a different way. And then if you go to this part right here, it shows you the whole piece model, which is kind of neat. So it tells you what you need to do. So planning, event complexity, assets, communication, supervision, and environment. And then it goes into the STAR model here, which is exactly what Samantha just talked about. The whole, it's kind of hard to show, spread out, transfer, avoid, accept, and reduce. And this is how you look at risk management when you're underway. And it's pretty decent stuff. And then it goes into the old, the GAR 2.0, which is when you put them all together. It's the same stuff here, but again, no more numbers. They made it easy for people like me to math very well. And it's just low, medium, high. And then as you go through these things and you're talking, you pick which one you think the mission's going to be down here. Figure out, okay, what's the level of gain that we're going to get for the level of risk we have? And it shows you down here whether it's an acceptable mission. So if it's low, if it's high gain, low risk, you're taking it all day long. Same thing with medium gain and low risk, and same thing with low gain, low risk, right? All day long we're taking this. But when we start getting down here into the yellow, the medium risk, and the high risk, it gets very, very questionable, right? So if it's high gain, you're probably going on that mission as long as everybody's good to go. Medium gain, probably so. But then if you get to the low gain with medium risk, that's where your commands got to get involved. It's where that ordering, issuing authority to OIA has to get involved and say yes or no. Down here, high risk, you'll notice it's all red. The only time you're going to accept it is if you have a command endorsement, and if there's high gain or medium gain. Most of the time, we're still not going to get these missions, but they're there. You can. Over here, low gain with high risk, forget it. You're not getting underway. It's not happening. It's too risky. It's not worth the risk that you're going to have to take. And it has one for each different thing we do. So let me kind of minimize this out a little bit. So you've got your ashore assessment. So you can do it when you're on a shore. You can do them when you're doing aviation risk assessment. So I'm an air crew. I'm not a good boat person. I throw up just looking at them. So this is what we use when we fly. We use all this stuff here. Same stuff, but it's all based off of low, high, medium. And it's just an easier way to do the risk assessment compared to the old GAR model, which was, 1 through 10. You had to add them up and then divide by 4. It was, it's kind of insane. So I can send these to Bob if he wants to send them out to everybody. But again, if you take your risk management course, which you'll be required to take if you're going to be operational in just about everything, it's all written there, and it's super easy for each
It's all in from the directorate too, from when the PowerPoint and all included in the directorate. And the other thing is that they used to game the system, right, with the old numbers. So we'd be like, we want to get out on the 17. Okay, let's put this. We're gonna make this a 3 and make that a 1, so that we can get underway. And so this now is we become, as I teach risk management as well, I'm a facilitator, and you have a discussion now, and it really does encourage to have the discussion with the crew. Everybody's involved, and you review, so are you high, are you low, and we're going to be a medium, so we're going, or a medium, low, we're going. And you pull that in, and you, as Rob just said, you change, It's a living number, it's a living thing. You do all the time when we're on water. Continually take assessments.
It's a good thing if you get those forms from Bob. It's not a bad thing to laminate and have in your book and stuff, especially if you're going through boat crew training or air crew training. It's very, very valuable to hang on to. Eventually you kind of start memorizing it and you're good to go, but it's a great tool for someone like me who wasn't, Mr. Math, and maybe I wanted to go out more than I was worried about, some things. It makes it a little bit harder for people to be dangerous. And that's really the name of the game, because the last thing we all want is to become a case study that's in the risk management training. And believe it or not, it happens every year. So don't be that person. Be safe. That's all I got, Bob.
Excellent. Thanks, Rob. I appreciate you sharing. Before we get into a C story from Bill, which I'm looking forward to hearing, does anyone need me to explain how to use the National Testing Center? I did a couple weeks ago, but I could do it again. Does anybody need that? Speak up. You can unmute yourself. Does anybody need that? Because
I'd like to hear it one more time, please.
All right. So I'm going to share my screen real quick, and Bill, then we'll get into your story here. So what you do is you're, see if I can figure out how to do this without, see if I can figure it out. So what you do, you get on your computer. See if I've got this page. Probably can close a couple of these pages, huh? At least I think I can close a page. Here we go. All right, so you get on your computer and you look up auxiliary NTC for National Testing Center. So then you hit enter, and that will tell you here's how to do the National Testing Center. So you click on that, and I've already signed into mine, but in order to do that, you might have to enter a password, which is the same as your, I think, auxiliary directory password. So for my computer, I've already, it asks you if you want to have your password saved, which is what I did. So now I go on here and it says, here's the National Testing Center 1.2. And you may need to put in your password. Now, if you've never used the National Testing Center before, you may have to go through the process of setting up a password. It's a little intimidating, but it's not that hard. And there are people through the National CS department that can explain it to you very clearly so that you're not confused. So here I've got my username, which is my member number. Down here is my password. This saved it for me, which is nice. So I just sign in, and boom, I'm already in the National Testing Center, and it says, what test do you want to take? And it shows all these tests right here, and you go all the way down here to weather. And you click on weather, and it tells you that you need a 90%. It's an open book test. I don't know how much longer that's going to be, so I would encourage all of you that have worked really hard to study in this class, take the test, within the near future, so that you don't miss your opportunity. You get 2 hours to take it. It's not going to take anywhere near that long, probably 35 minutes. As of now, there's no proctor required. You used to need one. 50 questions, and this is for the AUX WEA, the program, the AUX WEA program. So what you would do then is it tells you in general, got to get a 90. You can go backwards and forwards. There have been some different browsers that have had problems going backwards and forwards. And it is possible you could get a glitch in the system that'll kick you off suddenly. So theoretically, you can move back and forward, but that may or may not work very good depending on what browser you're using. You have the ability to put a flag on a question in case you've got some doubts about a question, you want to go back to it. And at the end, it'll say, are you all done? And when you click, yes, I'm done, I want to submit my test, it should populate with your correct answers. Now, this part, right when it grades it, has been a little twitchy lately. There have been some gremlins in it, so that sometimes it will give you guidance on your correct answers, sometimes it won't. Good. Anybody questions on this right now? Because I'm going to go ahead and stop sharing.
One quick question, Bob.
Okay.
The questions on the test, are those the very same questions that we've been seeing on our chapter reviews?
Many of them are, and then some will be different. But remember, it's an open book test. So if it's a question about the 300 millibar chart, you know, you can go look in your student study guide for the section that talks about the 300 millibar chart. You know, if it's something that you don't remember the answer, you don't remember seeing it as a practice question, you can still find the answer for it. And remember, you get 120 minutes, and it's only going to take about 35 minutes. Now, if you fail, is it the end of the world? No, you can take it again. The biggest issue I have is not students having trouble getting the answers right. It's this last problem here. When you're done with the test, it's been a little glitchy. So sometimes you'll take the test, hit submit, and the screen will like go black or something like that. And you're like, oh my gosh, did I lose everything? And then the next day, come to find out you passed, it just glitched out a little bit. But overall, it's been really nice to be able to take these tests through the National Testing Center. If for some reason you busted your butt and you take the test and it glitches and you're really upset, please take the test again and just hang in there. You've worked really hard to get ready to take this test. It's frustrating, and I've taken tests where it glitched out on me before, but you've got all the knowledge, you know, you've got all this stuff in the noggin right now because you just finished the class. And please take this test soon while you can still remember all the stuff. So I'm going to go ahead and stop sharing now. Any other questions before I do that?
There's an index in your book that goes by titles from everything, and it tells you what page to look on for it.
Yeah, so it's designed because you worked hard and studied all these classes and work hard with us and gone over the practice questions. You know, we're hopeful to see you guys take this test soon and do really well. Good. I'm gonna, we're gonna have a fun C story from Bill Luckshaw, but before we go, has anybody got any questions about the class? Because once I'm done with the review right now, talking with you, if you want to take off, you can. I don't want to hold you here if you got to get up early like some of you guys on the East Coast do. Does anybody got any questions? Bill, take it away.
Okay, thanks, Bob. Bill Luckshaw here. I've done 8 MAC races and a couple on my boat, and I wanted to share a story where a crew on another boat was hit by lightning and what happened there. So we're up near the Mac Island there, and a sudden storm came in, and on this other boat was like 40-foot sailboat. This crew guy was his hand on the lifeline, you know, and then his foot was on the pedestal, the steering pedestal that goes down to the rudder. So lightning came down through the mast, jumped onto the lifeline, went through his arm, through his foot that was on the rudder post, and severely injured his foot. And so they had to immediately take off to a hospital. So I just, you know, when they were talking about don't touch things metallic, this is what happens is, you know, and sometimes, you know, if you're steering the vessel, maybe put a rope or wear some gloves or something to, if it's a metal steering wheel like that. So any questions on that?
Good stuff. Very good. Samantha, tell us a little bit about your experience in Antarctica, where you guys can hang around if you want to visit. You're welcome. This is fun time. Was Vice Admiral Sandra Stolz on your boat with you, Samantha, or no? This is a book I'm reading for leadership regarding someone who had a chance to do some work on the icebreaker.
Yes, she was not, but that is on my to read list. So the Polar Star is currently our nation's sole heavy duty icebreaker, which is kind of problematic. But I had the opportunity to go aboard for Operation Deep Freeze 22 as a culinary assistant. So part of what I do in the auxiliary is went through culinary training for the auxiliary. So there's a lot of places that I can go to fill in for active duty slots. So there's places all over. You can go out to sea, you can go to Coast Guard station. Hopefully coming up, fingers crossed, I'll be in Key West soon. Down there for filling in for a culinary specialist who's out for like a broken leg or something like that. So it's a really cool job to get training in if you like to travel. And I love to travel and scuba dive. So I took this opportunity as like a long 6-month diving trip, plus to go to Antarctica, which is on my bucket list. So that's how, as an auxiliarist, I got on the Polar Star. So there were 3 auxiliarists on the Polar Star. And prior to that, only 1 previous auxiliarist has ever gotten to go to Antarctica on the Polar Star. But he had like a special job as like an engineer or something. So I went as a culinary specialist. I had the opportunity to do some additional training for lookout and helmsman, did my advanced damage control training, and earned my cutterman. So I just took a lot of advantages that were, given to me as a crew member aboard the Polar Star. So we got to sail through some pretty amazing and beautiful places, visit Hawaii and New Zealand, but Antarctica was by far my favorite. When you read the peace model, everything about the mission of the Polar Star is in red. So so I was laughing when we were going through that, because everything about it is in the red, except for you literally have a line straight to like the commandant from the captain's cabin of everything that you need, you're going to get because you're the only one of that vessel. So it was pretty cool. We even had some vegetables flown into Antarctica because the captain is a vegan. And so we didn't have any more fresh vegetables. So the Polar Star is like royalty in the Coast Guard. So that was pretty cool. I got to learn a lot. We had some NOAA scientists on board studying different things and actually doing some underwater sonar in Antarctica so that we could chart out and map an area for the new ice pier that's going in. So we don't have a real pier down there. So we were docked to an ice pier, and they were going to build another one. So basically they'll cut away different ice next year. So there's something new to dock to. Got to see Shackleton's cabin or hut down there, which was interesting because they purchased it in Australia. And so it was actually built for warm weather and not cold weather. So the crew actually slept outside more than they slept inside. And there's still a seal outside the front door that they killed over 100 years ago. But due to the low humidity and the extreme temperature, it has not decomposed. So that was pretty fascinating. The penguins are adorable, especially the emperor. They literally will walk right up to you and stare at you and squawk, and they think you're the strangest looking penguin they've ever seen because we didn't talk back to them. And they would hang out on the gangway at the end of our ship like, hey guys, what are you doing? Where, and like, we kept joking that we were going to kidnap one and throw it in the freezer, but that would be felony. But the penguins are adorable. The sea life is amazing there. Within 24 hours of arriving and breaking ice, the orcas show up because they're on new feeding grounds that are only open to them once a year when the Polar Star goes down there. So it's very fascinating because they've been conditioned to either the sound of an icebreaker or the polar star, but it's been in service long enough that like the matriarch of the pod would still have been around for the past, 40 years that the star has been going down there. So it's pretty cool historically to have them come up and watch them spy hop and hunt the seals and hunt the penguins. And we're just lucky they don't have opposable thumbs. Like, we don't need to worry about the apes. If orcas had opposable thumbs, we would be in trouble because they are extremely intelligent. So it's a rough ship to be on. No air conditioning, heating kind